is Geometry Chapter 5. Chapter 5 Review. Geometry deals, Chapter 5 deals with triangle bisectors. The four primary bisectors that we're going to look at are perpendicular bisectors, angle bisectors, zoom out a little bit, medians, and altitudes. Okay, perpendicular bisectors bisect a side at a right angle. They do not have to come from the vertex of a triangle. They can come from anywhere. They just have to bisect it at a right angle. The point of concurrency for the perpendicular bisectors is called the circumcenter. The circumcenter. Okay. The circumcenter is equidistance to the angles. Equidistance to the angles. And that's important because it's going to be a little different for the medians. So perpendicular bisector, what you need to know, bisects a side at a right angle, and each triangle has three perpendicular bisectors. Their point of concurrency is the circumcenter, and the circumcenter is equidistance to the angles of the triangle, or vertices. Angle bisectors bisect each angle of a triangle. Okay? So you'll have three angles. They'll all three be bisected if we were looking at the angle bisector. Their point of concurrency for the angle bisector is called the end center. The end center of the triangle. The angle bisector, or the end center, is always inside the triangle no matter what. The end center is always inside. I guess I should have told you this before. The perpendicular bisector, if it's an obtuse triangle, the point of concurrency, or the circumcenter, lies on the outside of the triangle. If it's an acute triangle, it lies on the inside. And if it is a right triangle, the circumcenter would lie on the hypotenuse. But back to angle bisectors, end center, always on the inside of the triangle. It is equidistant to the sides of the triangle. Equidistant to the sides for the end center. Okay, medians. Median of a triangle, it just bisects a side. Bisects a side. Median comes from the vertex of a triangle to the opposite side and bisects it. The median point of concurrency is called the centroid. And the centroid is 2/3 of the distance, from the vertex to the side. That is the centroid, which is the point of concurrency for the medians of a triangle. Lastly, the altitudes of a triangle. All the altitude does is a segment from a vertex to the opposite side at a right angle. The altitude is a segment from the vertex to the opposite side at a right angle. The point of concurrency for the altitude is the orthocenter. Orthocenter. There are no special distances for the altitudes of a triangle. Okay. Another thing you need to know from Chapter 5 is within a triangle. So we'll say within a triangle, opposite the smallest angle is, scroll that up for you, opposite the smallest angle is the shortest side. So that's the first thing you need to know. The second thing you need to know, opposite the largest angle is the longest side. Okay? So if I had a triangle, say for instance, we call this triangle A, B, and C, and I told you this was 30 degrees, 60 degrees, we'll call it a 30, 60, 90 right triangle, then the longest side is AB. AB is the longest because it's opposite the right angle. It's also the hypotenuse, therefore it's the longest side. The shortest side would be CB because it is opposite the smallest angle, which would be 30 degrees. Okay? Alright. Also from chapter 5, you need to know what a mid-segment is. Mid-segment. A mid-segment is a segment that connects the two midpoints of the sides of a triangle. So if I had a mid-segment, I'm going to draw you a triangle first. Here's a triangle. We're going to call it A, B, C. We're going to say these two are congruent. These two are congruent. So here's my mid-segment. This would be DE. DE is the mid-segment of that triangle. Therefore, the mid-segment is 1/2 the length of the side that it is parallel to. So mid-segments are parallel to the opposite side and they are 1/2 the length. So if the length of this were 10, then the length of the mid-segment would be 5. The converse of that statement would say if the mid-segment was 8, then the side opposite it that it's parallel to would be 16. So mid-segment's pretty easy to find. Also on a mid-segment, you can have what's called the mid-segment triangle, which is inside of it. The mid-segment triangle has a perimeter that is exactly 1/2 the size of the larger triangle. So if you need to know the perimeter of a triangle that's made from the mid-segments, it is exactly 1/2 the size of the larger triangle. Last thing from this chapter that you need to know is when we're talking about a triangle, there's a way to check to see if a triangle can have the given side lengths. So if I had a triangle, let me get where you can see that, and I told you that the lengths of the sides of a triangle were just say 4, 7, and 12, okay, you would take the two smallest sides, which would be 4 and 7, add those together. 4 plus 7 is 11. The two smallest added together must be larger than the remaining side. If it's not, then it's not a triangle. 11 is not larger than 12, therefore that is not a triangle. An example of one that would be a triangle would be, for instance, a 3, 4, and 5. 3 plus 4 is 7. 7 is larger than 5, therefore that is a triangle. Probably the easiest part out of that chapter. Also understand too what the Hinge Theorem is. The Hinge Theorem of a triangle states that if you have two triangles, this is the Hinge Theorem. If I have two triangles and this side is congruent to this side is congruent to this side. So we have two triangles. If they have corresponding sides that are congruent, if the included angle for this triangle, let's say it's 100 degrees, and the included angle of this triangle is 70. So this included angle is larger than this included angle, therefore the side opposite, or the third side of this triangle, is going to be longer than the third side of this triangle. So the Hinge Theorem says basically that the larger an angle opens up, then the longer the side opposite it, just like the hinge on a door. The wider you open the door, then the longer the side opposite it. So major thing to know from chapter 5 are the triangle bisectors, perpendicular bisector, angle bisector, median, altitude. their point of concurrencies, know the relationship between the opposite sides of a triangle and their opposite angles, understand the mid-segment theorem of a triangle, and lastly, understand how to prove a triangle, the three sides of a triangle can be by adding the two smallest sides together should be longer than the remaining side. That's it from Chapter 5, and good luck.